I've got Chameleon here trying to do voice recognition as I'm speaking, so hopefully he can answer as well.
So the first question is, where is it? It takes a lot of CPU to run. Is it a real resource hog?
One of the nice things I find about Vosk is it's a lot less resource intensive than some of the other options I tried. I've got it here, just trying to recognize everything I'm saying as we go along. And that runs at about 75% of one CPU on a Pi 4 right. when it's actively recognizing. So there's less than a quarter of the available processing power. If it's idle, it sits at about 20%, recognizing nothing. So that's pretty good. What I found when I tried some of the other options, like the TensorFlow or the Caldi examples, which uses a CNN neural net to do the recognizing, they were sitting at pretty much 100% all of the time. So this is a lot better as an option, I would suggest. Although I believe TensorFlow Lite is a lot less CPU intensive as well, but I haven't actually tried that out too actively.
Have you tried running this is a question from Dave. Have you tried running a Bluetooth headset at the same time as a Bluetooth controller, and did you get any interference issues?
Well, I use this PS4 lookalike controller, and I find no problem with it whatsoever. The only thing I've noticed is once you are using the Bluetooth headset, the Wi-Fi bandwidth goes down. I get about half bandwidth on my Wi-Fi when it's doing the voice recognition, but I haven't had any problem with the remote control, the PS4 controller at all. So yeah, I haven't worried about it. Yeah, whether I would see a problem, I don't know. We'll find out when I do a few more. When I do some of the videos, but yeah, I haven't seen it.
Cool. Is the audio recognition always running, or is it only at specific points in the challenge?
What I'm finding with the Vosk is I can run it all the time, and it's constantly just analysing the data and just providing. The way I've got my software, for the challenges, what I'm doing with the software is I've got a shared memory protocol between the different processes. And what the voice recognition is doing is constantly updating that shared memory. So then the main robot control can just see what the last spoken word was and take action on that.
Right.
In the demo that I did in the video, there was nothing. There was no shared memory, no threading, no anything. It was just looking at the video, looking at the voice stream. When it saw a recognized word, it moved the robot and then stopped after half a second. Waited for the next command. So there's other ways of doing it. Some of the examples I had with TensorFlow and with the Caldi, they worked in a slightly different way because they waited for half a second, then did a neural net analysis of that half a second, and then took an action. And so you could actually just go around in a loop, wait for half a second when you wanted to have a command, and then move on. But I find it with Vosk, I'm just doing a continuous recognition, and it's working great. No, as you can see, it's probably not. I'm probably speaking too quick for it to recognise. But yeah. if I speak reasonably clearly, it recognises very well.
Yeah. Oh, it even recognises me. That's weird.
Yeah, I've got the microphone next to the speaker, so.
Apparent Cyprian says apparently the latest version of Raspberry Pi OS actually breaks the A sound stuff.
Right, well, that's something I need to look at then. I haven't updated with this year's update, so I did do an update must have been over Christmas when I was doing the work, and it was okay then.
Right.
I'll find out. Yeah, what I'll try and do. It's not on the Dangle blog yet, but I intend to in the next few days put all the source code on there, and I'll do an update of this to see whether that causes any problems.
Yeah. When you were using, did you tried out TensorFlow, didn't you?
I did, yes.
When you were running the learning algorithm, did you run the algorithm on the Pi or on a PC?
I did it on the Pi. What I did, I paired my headset with the Pi, and then I did the learning through the headset that I was wanting to use. Because what I was finding is if you have a different voice quality, there's different characteristics of different microphones. So depending on the voice characteristic, it impacts the learning. So what I did, I just used a record to record 5 clips of 8 commands or something like that, and a few other clips of non-command words as well for comparison. And I just recorded a second of each, pushed it through the TensorFlow learning algorithm. That took, I think it was about an hour and a half to do the learning. And then, yeah, the recognition was actually pretty good. So cool. It was just the runtime. It was quite CPU intensive. So if you're doing other things in the robot, yeah, might impact it. That was all.
William Harvey asked, have you tried to incorporate voice with line following or OpenCV or anything like that?
That's what I'm currently trying to do. The example I had on there was really the up the garden path challenge was really quite a simple algorithm. All I did was wait for a recognized word, left, then I moved the motors for half a second, then stopped, and then waited for the next command and moved on. I'm just trying to integrate it with the rest of the robot software I've got on here, which is the line following is OpenCV, and what I'm going to do is have then it'll use the voice command it's recognizing in the background as a hint to whether to go right, left, or straight on. And I've got some of that working now, and I've posted some stuff on Twitter about the examples I've managed to get going, but I haven't yet successfully managed to navigate the full course with a combination of the two. That's next week's challenge.
Yeah. Have you thought about chaining up the voice commands? I'm not too sure what he means by that.
Well, that's what you would do with TensorFlow or with the Caldi libraries. You do a train a neural net and then use that, and you've got to really go through that process. For the VOSC, what I'm finding is the sample ones I've downloaded seem to work pretty well, good enough for the PyWorld challenges. So I haven't bothered to do it. One thing that might be reason you might want to do it is that the memory occupancy is quite large. It runs at about 600 megabytes on my Pi 4 with a 50 megabyte downloaded model file. If you recorded your own, trained your own commands, you could probably train like half the commands how many you needed, and it would be a lot smaller, and then it probably would run on a Pi 0 or something a bit smaller. I haven't tried to do it. I'm sure it's possible, but it's so easy to get the VOSC going that I just haven't bothered at this stage.
Okay. So I think we're out of time, actually. I just realized what the time is. So thank you so much for that really, really great talk. I hope that actually gives people a start on that challenge.
Well, yeah, I think it's so simple. I think, with using VOSC, well recommended. I hope wish everyone a lot of luck with it.
Cool. You're on Twitter, aren't you? Is it Media Blip?
At Media Blip. I did put it on the beginning of the talk, but if people call that.
Okay. Well, thanks for doing the Q&A as well. It's been really great. Thank you.
Thank you.